Okay, I'm going to give you an equation that was in the very first unit of this semester. Do you get that saying? Start with 25. And then do this. Do you get that would make it grow? Can you figure out two things? Number one, what would the, it's a trick question now, so be careful. What would the third term be? And secondly, make this into an exponential, which would look something like this. That is not the right answer, but that's kind of how an exponential looks. This will catch you up to where we were yesterday. The third term in that sequence, and then change it so these numbers are different, of course. Make me one of those exponentials. Okay, so here's the common mistake answer. Kid goes, all right, I know how to put this in my calculator. And they put it in their calculator. And then they find u sub 3. U sub 3 is not the third term. Yeah. You really, if you're going to answer a question about what's the third term, it'd almost be worth changing this to a u sub 1 and then find u sub 3. But that, or do it right and say, all right, I'll put this in the calculator. Better go into mode, make it in sequence mode. Then I want to go to y equals. I'm going to change this to a simpler 1 plus 0.05. Don't need the whole divided by 12 thing. I'm just going to put a parenthesis right here. I'm going to delete out the rest of that stuff. And I started with 25. Move that over. Third term, going to the table. Oh, it's taking a really long time. Do you guys know how to break that if your calculator gets stuck in this loop? Hit the on button. Very good. So I'm going to do that, and I'm going to break that. It says error break. And I say go to, and what were you doing with the break? And it was that. It was doing another one of those terms. So I wanted it to table to start at 0, and that's why it was giving me trouble. There. First term, second term, third term is u sub 2. 27.5625 or 27.563. All right, got that? All right. Now let's do a much tougher question than that. How do you make that into an exponential? It's really not that hard, but starting growth rate to the x. So how is that any harder? Because the follow-up to it is, what if that's down the road, your 25 grows to 100? How long did it take to grow to 100? And really what you're going to have to do now is solve an exponential. And that means you're going to have to remember a whole different branch of math called what? Logs. Now, I do want to give you a heads up that next year when you're in honors pre-calc, at the end of the year, there's this really tough lab. It's not even that hard, but it's at the end of the year and everybody's burned out and stuff. And there's a technique that I'm about to show you that would work. So if you've got a good memory, that can last till next year at this time, 1 year from now. This is a technique that'll solve any weird, tough equation. You know what? I don't even need logs. If I know this technique, graph both sides and see where they cross. Y equals 100 and y equals all that. They will cross. You know why I know? Because y equals 100 is just a straight line going like this. And this other one is an exponential. It goes like that. They will cross. And wherever they cross, that's the answer. I think that that's the least known way of solving equations. Everybody knows how to, like, you know, divide both sides by something, add both sides to something. You just graph both sides. and see where they cross. It's a really powerful method. I know I've mentioned it at least once or twice this year. I'm going to mention it once or twice next year, and then the end of the year is going to come and people are going to be like, I don't know how to solve this really hard equation. What can you always do? Graph both sides and see where they cross. Even if it was really, really weird, like 2 cosine theta minus 1 equals 5 sine theta. And you'd be like, I couldn't solve that in 100 million years. What if you graph both sides and see where they cross? And what if they don't cross? That means there's no solution. If they do cross, then that's the solution. It's not that hard, and it's a really, really powerful thing. You could use this on probably, I'd say 4 times every ACT test. You could have graphed both sides of an equation and see where they cross. The hard part is, I'll admit, it's kind of slow, and you don't want to be slow on the ACT. But especially like in a hard pre-calc math class, when you're doing a lab and you got this weird, hard equation to solve, pull it out. It's a great strategy. Graph both sides, see where they cross. We'll see who in here remembers that. Okay. Now, if you want to solve this the normal way, then you have to know how to do logs. And let's see if your log has left you. Any hard equation that you're going to solve by hand, you know, this is not graphing it, you got to start looking for adding and subtracting. Is there any adding or subtracting I could do? Okay, notice I'm going backwards of the order of operations. Next, I'm going to look, is there any multiplies or divides I could do? Yep, I could divide by 25. And that works really nice because that's gone, and that turns into, that's supposed to be a 5, sorry. That turns into 4. And again, though, it would be a little easier now to graph both sides and see where they cross, but that's the only way I know, other than logs. So do you remember how to do logs for this? Int, it's log base something of something, and your calculator can do it. Which of these kind of looks like a base to you? The 4 or the 1.05? 1.05. So that's the base. And then try to remember that logs always jump back and forth, back and forth. Okay? So log base 1.05 of 4 equals x. Look at that. X is alone. That means it's solved, and that's your answer. Do you know how to type it in? Grab your graphing calculator. If you don't know the right process, I'll remind you a way that works for all calculators is log 4 divided by log 1.05. And I get that a lot of you have already got that. Raise your hand if you've already got that. Okay, awesome. What do you have, ma'am? 28.41. Can anybody verify 28.41? Okay, awesome. What does that mean? That means if I put a 28.41 right there, it should equal 4, or because we rounded, it's probably not going to be exactly 4, but it'll be really close. Okay, let's see if you really have logs down. Here's a few other loggy things. Could you solve that? Don't say it. Solve it. Write it on your iPad. I got to take this. I'll be right back. All right, so that last one, we just had to rewrite it. Go this to the this equals that. I'm going to go backwards now. What if I had 5 to the x equals 14? Can you rewrite that back into a log? It's just all about going back and forth between logs and exponentials. You're going to do this again next year, so if you kind of like logs, you're in luck. You're going to get more of them. If you're like, oh, I hate logs, get used to them. They're not going away. They're going to be in pre-calc, and they're going to be in calculus after that. So just get used to them. Did you say log base, which looks like a base here? 5 of 14 equals? All right, there we go. Okay. Next. What if the x is in a different place? Log base x of 2 equals 1. What? Pause for a second while you try that one. Okay, so some people having an inane argument about x is equal to 2, or x to the first equals 2. Anyway, x to the 1 equals 2. I agree with that, and I agree with x equals 2. Raise your hand if you had that one right. Okay, then here's a harder one. Do you remember log base e? Okay. Let's say it was this. First of all, people get confused. They're like, how do I solve it? It is solved. You know why? Because x is alone. So that's the answer. Well, then how do I know what that is? You use your calculator. Except you got to know what log base e is called on the calculator. ln. So that's ln3. 1.09 blah, blah, blah. Well, what is that? That would be like this. E to the x equals 3. And 1.09 is apparently what you can put e to and get 3. Okay, so here's another way this kind of unwraps. I know the answer to that. Do you? My tip for you is anytime you see ln, you replace it with log base something. Okay, in this case, log base e. ln can be replaced with log base e, so I'm going to pull this out and put in log base e of e to the 7th, and that should ring a bell. The bases are the same. And here's my saying on this in logs. If bases are the same, the answer's already there. I don't want to just say where the answer is, because sometimes the answer is the exponent, sometimes the answer's somewhere else. But if the bases are the same, the answer's already there. And the answer to this one is 7. Why do I say that the answer is already there? What if it was like this? E to the ln 5. What did I say to replace ln with? So e to the log base e of 5. Are the bases the same? So the answer is already there. So the answer is what? 5. That one's harder to process in your head. If you don't get why that's 5, I understand, but I'm going to show you just real quick. Would you agree there's no variable? There is no variable here. I'm going to say equals x. E is not a variable. E is a number. In case you don't remember, it's like 2.718, blah, blah, blah. It goes on forever. It's above the divide sign on your calculator if you want to see a longer version of E. It's above the divide symbol. Anyway, so if I want this answer to be 5, I'll show you why it's 5, because I can rewrite this as a log. You might be like, but it's got a log already. It's actually an exponential form right now because there's an exponent here. So I'm going to write it as a log. Log base, what's the base? E of, and then remember how you jump around back and forth? Log base E of x is equal to log base E of 5. And what do you know? There's log base e's on both sides, x equals 5. Did you remember that if there's a log with the same base on both sides that you could cancel them? You're learning so much right now. All right, what if you add logs? Good point. Log base 2 of x plus log base 2 of 5 is equal to log base 2 of 20. What if you add logs? Well, you can't solve this until you get it down to just one log. And if there's one log on each side, then you could cancel them if they're the same base, which we pretty much will make it the same base. You're in easy class right now. When you get to pre-calc, it might be harder than this, but okay, so how do you do this? You got to add logs together. Do you remember that add and multiply kind of go together? Like if I said 2 plus 2 plus 2 plus 2, I could have said 4 times 2. Add and multiply kind of go together, right? Do you remember that dividing kind of goes with subtracting? All right, anyway, so back to these two are being added. Try to solve this one by doing that deal where the 2 logs adding kind of turns into 2 logs multiplying. If you have completely forgotten this, I will show you in a second. But try to get this to be just 1 log base 2 of something. And I'm just going to copy this down, log base 2 of 20. Do you get, then I'll have log base 2's on both sides, and I can cancel them. So that's why I want to get it to just one log. What do you think? I think it's 4. How about this? Log base 2 of, you jumped right to the answer, and I think you might even be right, but can you tell me what was right here? Log base 2 of what? 5x is correct. Did you get what happened there? He took these, and they're called the arguments, and he multiplied them. Now, these can cancel, and you are correct. X equals 4. Do I need to do another practice of that? Or, again, I don't want to bore you, but I also don't want to go too fast, so it's a kind of a fine line. Nobody indicated they wanted another, so we will keep going. How about this one? I got a lot of people confused with this last hour. Log base x of 0. Explain.
I don't know. I thought
What do you mean it can't happen? So what's the answer? There's no solution. Can't do that. There's a reason. The argument can't be 0, and it can't be negative numbers either. The arguments in logs have to be numbers bigger than 0. They can be decimals even, but they can't be 0 and they can't be negatives. All right. How about this then? This is different. Log base 0 of x. Official answer you'd write down? No solution. Why? Because you can't have bases that are 0. There's one other base you can't have that a lot of people don't know. I think you all would know that a negative base is a no-no. But how about a base 1? Can't have it. No base 1s. It's illegal. I'll show you why. If you had a base 1 in this situation, it would be impossible. So they outlaw a base of 1. I'll give you an example. 1 to the x equals 5. Think about it. I know it seems like there should be a number you could put there. There's no way to do it. You keep putting 1 to a power, guess what you get for an answer? 1. What if you put it to a bigger power? You still get 1. So you can't get it to be 5. So you can't have a base of 1. All right. One last little weird thing you should know is if there's a 1 in another spot, something big happens. Yes. Do you remember the dumb little saying for this? You won the argument and you get nothing. That's usually true in arguments that don't matter that much. Pepperoni is better than sausage. And if I could prove sausage is actually better and you just didn't know that, well, yeah, it's a stupid argument and you'll get nothing. All right. This one's 0. Why? Because think about it. X to the 0 equals 1. All right. So the answer is 0 for any time the argument is 1. All right. There's a bunch of log stuff. Is there anything else you have to know? Oh, yes. So next unit we're going to talk about is the kind where you have graphs that get shaded underneath them, and then you shade underneath this. You remember that? You actually did really well on that test, but I know it's been a long time. So this is the kind where there's like a feasible region. Remember that kind? That is called linear, can you finish the sentence? Programming. All right. So this is the kind where you'd have like, oh, the answer is this spot, or this spot, because Mr. Server said it's not 0, 0, because then the answer is never to just shut down the factory. Okay, you want to minimize your costs or maximize your profits, but if you just get 0 and do nothing, that's not good. Okay. I'm going to give you 2 equations of lines that cross. I'd like you to shade them and use the common sense that you can't create negative of these things. Let's say there's Oculus Company. Right now, Oculus Company is making, as you see on my desk here, the Oculus Quest and also the Oculus Go. They still make both. The Quest is like $400, the Go is like $200. And they have to decide how many of these are we going to make? How many of those are we going to make? Why don't they just make one of them? Well, because some people don't want to spend $400 on this. They'd rather have a $200 one, and so they want to have both. Why doesn't Apple just make one iPhone? Because people want choices. All right, so they're going to make some of these and some of those. Here's an equation. I'll save you a lot of time of a really complicated long problem. If it boiled down to this, y is less than or equal to 2x plus 8, and here's the other equation. Y is less than or equal to negative x plus 9. And my question is, sketch it, include the common sense constraints that x has to be bigger than 0 and y has to be bigger than 0, and find the vertices of the feasible region. Find the little corners. Vertices. All right, I will hold just a moment or pause just a moment while you try this. Okay. There's one of them. Here, I'll do them in the same colors that they were in. There's that one, and it's shaded underneath it. That's the black one. The blue one looks like this. And the blue one is shaded underneath it. And then if I do the common sense constraints, I would stay in here. And from my experience with these tests, we have usually got a sucker answer in there, which is that is one of the points that we have a dot on. And then so kids will be like, ooh, that one gets me the most profit. Can't use that one because it's not part of the what? Feasible region. Okay. So this one is part of the feasible region. This one is part of the feasible region. This one is too. And so is that one, but I'm not even going to put a dot there because I told you we're not going to tell you that 0 is the best idea for making your products. Okay, this one, or this one gives you the most profit. Well, how would you tell? Well, first of all, you got to know what those points are. This one's pretty easy because it's the y-intercept. Finish this sentence for me. The y-intercept is where x equals 0. I put a 0 here and I'd find out that it's y equals 8. So that's easy. That's about right there. I know it's y equals 8. X is 0, who cares, but y equals 8, 0, 8. Okay, this one, that one's harder. You gotta try to solve a system of equations. Are you kidding me? You have to actually do math? Well, I would recommend you put that there, and you'll have 2x plus 8 is less than or equal to negative x plus 9, and 2 steps later, you'll have an answer. It's not that hard. Option B, you actually graph them on a calculator, and you hit second calculate intersect. It's an option. I want you to remember the second calculate intersect way, so grab your calculator. We're going to practice matrices on Monday, so not doing matrices today. The last couple things we have are matrices and stats, which we just did. Oh, and probability, yes. So even as it is, we're going to have 3 major topics for Monday. Matrices, stats, and probability. All right, yes?
Whenever I go to trace my graph, it says invalid dimension.
Okay, that means that you can't see where the 2 lines cross. You've got to make sure that the place where the 2 lines cross is visible on your graph. So go to your window and make your window probably bigger so that you can see where the 2 lines cross. I'll pause for a second and pull it up on my calculator. Okay, So I'm going to remind you how this works on your calculator. Y equals 2x plus 8, and y equals negative x plus 9. Enter, and then I go graph. And what if I can't see them like that? Ooh, better fix my window, otherwise if I try to do intersect, it won't be able to. So I'm going to make my window different. I'm going to hit the button called window, and I'm going to go maybe just smaller dimensions, like negative 15 to positive 15 in both directions, maybe. Negative 15, positive 15, and then I graph. And will I see where they cross now? Survey says yes. Second, calculate intersect. This is a good one to know. And it's one of the easy ones because as long as you only graph 2 lines, you can just go enter, enter, enter. And there's your answer. 0.3 repeating, 8.6 repeating. So final answer is yes, there's an intersection point of 1/3 and 8 2/3. 1/3, comma, 8 2/3. Any questions about that one? Oh, I never gave you an optimization equation, but if you were actually asked which one of these is the best, it would depend. I could make it so any of the 3 is the winner. If I make X have a lot of profit, then that'll be the best one because that's got the most X. If I wanted to make Y have the most profit, then that could be the best one. Actually, I don't think I could make that one give you the most profit because the other one's got more X and more Y, so I don't think that could ever win. So it'd be one of these two, and it would depend on your optimization equation. So that's one more last thing to mention. Let's say I get $20 profit for each X and $10 profit for each Y. 20 for each X, 10 for each Y. Profit equals 20 for each X plus 10 for each Y. That's a profit equation. You never graph them. You just use them to see which of the vertices is best. Okay, I get the feeling that I probably could try to teach you more and it would just fall right out of your head because you're tired and you need to be done. So, what's your homework? You have to create your own homework. It takes a little bit of discipline. I hope you have it in you. I'm not saying that you don't. I hope you do. But your job is to screenshot a bunch of things that you try. Like try taking, maybe you need to take a Schoology quiz on probability. I haven't even talked about it yet, but maybe that's your area of weakness. Work on whichever thing is your area of weakness. Take screenshots of it and be prepared to Dropbox it at the end right before the final. Any last questions? Okay, the rest of today will be work time.